Okay, to summarise where we are so far, generating labels onto objects in the render tree in XSI. What we've done is used a matte to composite two shaders together, an illumination node shader for the area outside of our label, and another illumination node for the inside area, which has a texture on its diffuse input, using the matte to composite those two together. We've used an image file as the matte for convenience, but here we're going to look at a method which saves you generating that matte externally to XSI. We're going to generate that matte area inside XSI in the render tree. Let's have a look and see how we do that. This is our object, same object as we had before, NURB surface mesh with a Phong shader on it and two projections. Bring up the render tree. This method makes use of the fact that UV coordinates inside the area of our label lie in the range 0 to 1, and UV coordinates outside of the label lie outside of that range 0 to 1. First thing we need to do is get hold of our UV coordinates, and we use a TexasBased Generator node for that. TexasBased Generator allows us to pick projections from this drop down here. The drop down is currently empty. That's because it's not connected through to the final object. It has no idea what the object is or where to get its UVs, but as soon as we've connected that through, we'll see that in the drop down. So we'll come back to that later when we've got it completely connected. The next node is from the Math submenu, and this will be a ScalarInRange node. ScalarInRange node takes a minimum threshold and a maximum threshold and an input, and it produces a Boolean value of true if the input lies inside the minimum and maximum range, and a value of false if it lies outside the minimum and maximum range. Plug the output of the TexasBased Generator into the input of the ScalarInRange, and that's produced a conversion node from the texture's vector output to the ScalarInRange's scalar input. Double click on that, and we have the option of outputting the X, Y or Z texture coordinates. That's a bit confusing for me. They correspond to the U, V or W ranges from the TexasBased Generator. So here we're going to use the U coordinate or the X value in there, and that's our little tree there. We need to convert that Boolean output into a colour so that we can make use of it, and we use a switch node for that. This will be the colour switch node. It says colour in the menu, and just to make things completely confusing, it's called a Boolean switch on the node itself. But the Boolean switch takes a Boolean switch input, as it suggests, and it has two colours there. It will output one of those colours if the input switch is true, and the other colour if it's false. Let's see how that works. Put the output of the Boolean switch temporarily into the diffuse component of our Phong shader and have a look at that. There we go. We've got a thin strip down there which doesn't appear to make an awful lot of sense, but that's because we need to set the minimum and the maximum threshold ranges to something that corresponds to the UV. So minimum for minimum of 0 for our U equals 0 range value, and maximum threshold of 1. And there we've got a nice blue band down in the middle. If I bring up the front view here, you can see that the boundaries of that blue area there correspond exactly to the left and right areas of our texture projection. If I open up the texture generator now we do have drop downs there because we've connected through, and that's our two projections there. If I change those, we're not going to see an awful lot of difference because those two textures line up pretty well. But opening up the vector scalar node, if I change that to a Y, which is the equivalent of the U coordinate, you can see that that band now corresponds to the top and bottom of our texture area. So that gives us part of our matte. To cut it off down the side here, we're going to duplicate this tree here from the ScalarInRange back. Control C, deselect Control V. Lovely new feature of XSI version 3. You can cut and paste render tree nodes. Great time saver there. Plug that into that switch, and beg your pardon, and this node here, we'll change that to an X. So we now have two subtrees here, two branches here, one that corresponds to the U and the other that corresponds to the V, and we need to figure out how to combine those two together. Well, the way we can combine them is using another math node here. We use a Boolean logic node. The Boolean logic node, Boolean math logic node, takes two Booleans on its input, and it has an operator which is performed on those two inputs before it goes to the output. We've got three options there: and, or equals. We're going to use and. Plug the output of one ScalarInRange into input 1 and the output of the other into input 2. Move those over there so that we've got a bit more space. And plug that into the switch, and there, that fits our label really nicely. Take the Boolean switch, turn it into a black and white for our mat, like that. And that is the mat that we need to put our label on. Now it's just a case of doing exactly what we did in the previous method. We'll put a texture map on one input and a straight Phong shader on the other. Get an illumination Phong node there, plug that into the input there. Okay, so we've got Phong shader there. Duplicate Control-C, deselect Control-V, duplicate our Phong input there, put that on the other input, and then just get our texture node image there and plug into, I'm probably going to get this wrong because I can never remember which way around it goes, but put that into the diffuse there. No, I've got it right, brilliant. And that's our label. Very, very simple. So just to summarise, just bear with me while I tidy this tree up just a little bit so we can see it more clearly. There, 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 and there. So, to summarise, one other thing that we can do here is discard one of those texture generators. Because these are both the same, we can plug the output of that into both of these vector to scalars here and use the delete key to get rid of that generator there. So, TexasBased Generator, which is providing us with our UV coordinates, go through vector to scalar into a ScalarInRange. One vector to scalar is extracting our U coordinate and the other is extracting our V coordinate. Into the ScalarInRange with minimum and maximum values set to 0 to 1. The two combine together in, using a Boolean math logic, which goes into a Boolean switch, and that provides our mat. And we then have our texture plugged into one input and a straight Phong shader for the area outside of the label plugged into our Boolean switch there. And one minor mistake I've made there is I've left a Phong shader in there, so I'm going to bypass that to there and get rid of it. And that's it. That's labeling without having to generate a texture externally. Just one final thing before we draw this to a close is to take a look at how to put several textures onto an object using this method. It's very simple. For the mat, we daisy chain Boolean math logic nodes together, and this is how we do it. I'm going to duplicate this node back here, Control-C, deselect and Control-V to paste that into there, and bring down another Boolean math logic node to combine these two together. That goes in there, one in there, and one in there, and plug that into the switch. TexasBased Generator there for our second projector, and this time we need to use an OR in there to produce our mat. So that's our mat area for our second texture. Now all we need to do is to put a texture in there, and exactly as we did before, we use a color basic node to combine just our textures. Let's just put that over there out of the way, and I'm going to duplicate this node, this branch here, Control C, Control V, and that input goes in there, that input goes in there, and the output of our color math basic in there, and now change the texture projection in one of those textures to the second label there. Really very, very simple. So duplicate the tree from the Boolean math logic down below there, change the texture projection, plug it into another math logic which combines those together, and then use a color math basic node to combine the two texture labels there. There we go. Simple as that.